All right, we're going to be on page 45 in your journal, and we're going to be talking about ratios. So a ratio is a comparison of two quantities. So you're never going to compare more than two things with a ratio, all right? So if you had 3 triangles and 4 circles, if you were to write a ratio to compare those two items, a ratio is a comparison of two quantities by division. And I'll show you what the division means in just a moment. So if we were to compare 3 triangles and 4 circles, all right, and it might ask you it will ask you, what is the ratio of triangles to circles? As it's very, very important that if triangles comes first in the question with the question mark, that you put that number first in your ratio, and then circles comes second. So we are going to write 3 different ways to describe a ratio, right? 3 different ways. So your first way is to write it like a fraction. This is the most often, this is the one you'll see me use most often, because it is actually not a fraction. So if we write triangles to circles, okay, and we write it in a fraction form. So triangles to circles. So if we look up here, we have 3 triangles to 4 circles. Now, this looks like 3/4, but this is not a part to a whole relationship like a normal fraction, okay? This is a part to part relationship in this example, okay? In that example, it is a part to part relationship. So how you would read that ratio is 3 to 4. Okay, another way that you can write a ratio is 3 to 4 with a colon. And another way to write it is 3 to 4. So those are the 3 different ways. So on your homework on Monday, if it asks you the 3 different ways to write a ratio, this is exactly what it's talking about, those 3 different ways, all right? So then it might ask us, okay, we're going to find equivalent ratios. So equivalent ratios are very, very common, are very alike to equivalent fractions. All right, so you can only multiply and divide with equivalent ratios or equivalent fractions. All right, there's going to be no adding or subtracting. And this is where that division comes in. So see, remember how we have started writing division problems with that line. So this division up here that we were talking about, they are comparing it using division. Basically, you can treat it like a fraction, but you don't read it like a fraction. So you say 3 out of 4 or 3 to 4 instead of 3/4, okay? Because it is 2 different things, a part to a part. It's 2 different things that you're comparing. So let's look here. We're going to find equivalent ratios, we're going to multiply or divide both terms of the ratio. Okay, these are terms. Both terms of the ratio by the same number. So on Thursday, yesterday, we went ahead and did those dry erase sleeves, and whatever on that bottom section, when you were finding that missing number in the box, whatever you did to the top, you had to do to the bottom. Okay, and we only multiplied and divided. So here they're saying, okay, say 3 times 2 is 6. So I better do that same times 2 to 7. So this is times 2 times 2. So these technically are equivalent ratios. All right, so if I had 3 apple pies to 7 cherry pies, and then the next group had 6 apple pies to 14 cherry pies, they have the same ratio of pies. If I simplified 6 to 14, I would get 3 to 7. And that's the cool thing about ratios, is you can simplify them just like a fraction, even though they're not technically a fraction. They're a comparison of 2 things. So then we have apple pies. Let's say 3 times 3. Okay, and I always like to put my little things like this. 3 times 3 is 9. So 7 times 3 is going to be 21. And then 3 times 4 is 12. 7 times 4 is 28. So if all of these are going to be equal to each other. So if I cross multiply these 2 numbers and these 2 numbers and compared those 2 ratios, or I'm treating them like fractions, they would be equivalent or equal to each other. So we're going back here and we're saying 3 times 5 is 15. So 7 times 5 is 35. 3 times 6 is 18. So 7 times 6 is 42. So all of these are equivalent ratios. All right, so let's actually find a ratio. So let's answer some questions. It says 8 students of the class of 32 had ice cream for lunch. So it asks, we're going to find the ratio, okay, of students that had ice cream to total students. Those are the two numbers they gave me, okay? And I'm going to pretend they asked us ice cream to the total. So we have ice cream, 8 people had ice cream out of a total of 32. So 8 out of 32 had ice cream. Now, if I can simplify this, okay, we practiced simplifying fractions in our dry erase sleeves yesterday too. So if I can simplify these, if you need your green sheet out to figure out what factor, the largest factor that goes into both of them, okay, you're going to divide by 8, okay? 8 goes into 8, 8 goes into 32. So that means 1 out of every 4 students got ice cream for lunch. So you can simplify a ratio like a fraction, but you don't read it as 1/4. You read it as 1 person had ice cream to 4 total. So how many did not have ice cream? Well, let's think. We had 32 total. If I take away the 8 that had ice cream, okay, and this is our total. So if I go ahead and take that away, I get 24 students that did not have ice cream. I'm going to put IC for ice cream. They did not have ice cream. So let's write a ratio of people that did not have ice cream. 24 did not have ice cream out of the original 32. So this is a part to whole. This is different, all right? So you have to pay attention to what it's asking. If it wants a part to a part, like up here, or if it wants a part to a whole, like this. You just have to pay attention to the question. So just like this is 24 to 32, 24 students that did not get ice cream to 32 total students. So if you can simplify, simplify. So now 3 out of every 4 students did not have ice cream. So not 3/4, 3 out of every 4. Okay, that's how we would read a ratio. So what is the ratio of blue to green jelly beans? So let's look here. So blue to green. So I always like to label so that I make sure I don't make any silly mistakes. And I put it in that order. Blue goes first, green goes second. So blue to green is 7 blue to 3 green. Okay, so that's one way to write it. Now let's write it 3 different ways. It didn't ask us, but let's practice. So 7 to 3, 7 to 3, 7 to 3, 7 to 3. So those are 3 different ways that I can write a ratio. And they can present any of those ways on the test and expect you to know what they mean. So now this is a part-to-part ratio. They're comparing one part of the jelly beans to the other part of the jelly beans. Now it wants red jelly beans to the total. So now this is a part to the total. This is not a part-to-part. It's part to total. So we want red jelly beans to total. So how many red? 6. Now think about how we would find the total amount of jelly beans. Well, let's add them together. That right there is 10. That right there is 10. 10 plus 5 makes a total of 25. So 6 were red out of 25 total. And I couldn't simplify this, and I can't simplify this like we did over here. So we just leave it like it is. All right, and just to practice, let's go ahead and write it 3 different ways. There's 1, 2. There's the other way with the colon. And then the other way is 6 to 25 with the word 2. Okay, remember you can pause this at any time if I'm going too fast. So let's look on the back. So this is an example that you might see on a test or maybe on the STAR test. It says Tiffany and Percy each added the same amount of water to their buckets. Tiffany mixed 5 milliliters of plant fertilizer for every gallon of water. So remember, every or per or each means 1. Every gallon of water for her bucket. Percy mixed 6 milliliters of plant fertilizer with every 2 gallons of water for his bucket. Which of these statements is true? So it's talking about who is using more fertilizer per gallon of water. Remember, per means 1. All right, so I'm going to write Tiffany, and I'm going to write Percy, and I'm going to go ahead, and it's going ahead, and it's looking like it's comparing fertilizer to water. Fertilizer to water. So I'm going to go ahead and put fertilizer to water. So Tiffany mixed 5 milliliters of fertilizer with every, well, that means 1 gallon of water. Percy mixed 6 milliliters of plant fertilizer for every 2 gallons. All right, so these are ratios. Tiffany's is 5 to 1 and Percy's is 6 to 2. Now there's a lot of ways to think about this. All right, but if we treat them like fractions just for a minute to compare them, we can go ahead and see which one is larger if we cross multiply. I think she called it butterfly in 5th grade. So I can tell just by looking at these numbers that this ratio is larger. Okay, it is more concentrated with fertilizer than this one. Okay, all right, so Percy used more fertilizer per gallon. Well, we just said that Tiffany's was larger. Okay, so if Percy used more, we know that that's not right. Tiffany used more, we're thinking yes. Percy used more, no. And Tiffany used more. Okay, so we've narrowed it down to 2. So we have taken this ratio and compared it to this ratio. So let's look at their examples or their explanations. Tiffany used more fertilizer per gallon of water than Percy because 5 milliliters is greater than 2. Well, that's not quite, we weren't comparing these two numbers really. This was fertilizer and this was water. So let's look at this one. Tiffany used more fertilizer per gallon of water than Percy because 5 to 1 is greater than 6 to 2. Well, that's what we did. 5 to 1 was greater than 6 to 2. So when we wrote those ratios and compared them, we found out that that ratio was greater than this ratio. Okay, now remember, we wrote it as a fraction, but they could also write it with the colons. So it's going to be D. All right, let's look at number 2. Ginger mixed 4 gallons of blue paint with every 7 gallons of yellow paint. So there's blue, there's yellow. In order to make a shade of green paint. Which ratio of gallons of blue paint to gallons of yellow paint will make the same shade of green? So same, equal. So they're asking for an equivalent ratio of blue to yellow. So blue to yellow. So how many blue? 4. How many yellow? 7. And so now there's lots of different ways to do this, but if we were to take all of these and write them to look like a fraction, they would look like this. Okay? Now, if I asked you to compare this and see which one was equivalent to this, there's lots of different ways that you could do that. But what I am noticing is 4 is not half of 7. Okay, 4 is not half of 7 because 4 is half of 8. So I know that is equal to 1/2 and this is not. So I know that they could not be the equal or same. So I'm going to mark out this one. Now 10 to 12, let's say we don't know. So we can put 10 to 12 by the 4 to 7 and we can cross multiply or butterfly like Miss Sanders called it. And we are not getting equivalent products when we cross multiply. So we know this one's out. Okay, so let's write our blue to yellow paint again. And now let's compare it to this. Now I can cross multiply here, but I can also do like we did yesterday in that sleeve and say, okay, well, I'm gonna try to find a relationship here and here and see if they're the same relationship. So 4 times 5 is 20, and 7 times 5 is 35. So if I'm doing the same thing on the top and the bottom, then I know that these are equivalent. Okay, so C is gonna be my answer. I could also, and just make sure, compare it to 16 over 21. So this is times 4, but this is times 3. So they're not the same on the top and bottom, so I know that they're not equal. So it's going to be C.